Okay, then let's start building our object detector. So I've opened up the Colab notebook where we will build our object detector using RCNN from scratch. But before we start doing the training from scratch, let's just look at what we have learned so far. You know, the theoretical background of what we've learned. So we have looked at what RCNN is. So we have understood what RCNN is. We have understood what selective search is. We have understood region proposals and also non-maximum suppressions. And then we went into looking at transfer learning, because we'll be using transfer learning for our classifications. So these are the stuff which we have learned so far. Now we will apply these what we have learned earlier in building this classifier. So these are the processes which we will do. We'll implement. First, we will load the data using the annotated CSV file. So we have already prepared the annotated CSV file in the post 2. We'll be using the same CSV file which contains the annotations, the bounding box annotations, and the image IDs. Then we'll prepare the train and test set. So we'll split the data into train and test sets. And then we'll start with the transfer learning. So we'll create a classifier using MobileNet V2 and that's the network which we'll be using for the transfer learning. So as part of the transfer learning, first what we'll do is we'll warm up the network. So here warming up the network would mean we'll freeze all those layers. We'll only use the top layer or the custom layer which we built, and then we will train on the custom layer for some epochs. And then what we will do is after warming up, then we'll unfreeze some of these layers, you know, some part of these original layer of this MobileNet based network, and then we'll train using that. So what we'll do is we'll also compare the metrics between when we had frozen all these layers and then when we unfroze some of those layers also, and compare these the actual metrics for this. And then we will implement the real RCNN processes, which is the selective search algorithms, the region proposals, and then detection of those bounding boxes using the classifiers which we built. And then we'll apply the non-maximum suppression also, and this contains the old inference cycle. So these are the steps which we are going to implement in this during this training process. So let's get into the first one. Now let's start importing all those packages which we want. These are all familiar packages which you would have already seen. This is your the MobileNet V2 which we are importing, and then other packages are all familiar. And first we will load the CSV file which has the annotations. So please remember to change the path where your CSV file is kept, and this is how the CSV file is. Let's look at the head of it. So you have the file name, the width and height, what class it is. We are interested only in the pothole class anyway, and then the bounding box coordinates here, x min, y min, x max, y max. And then next we will open up two empty lists wherein we will store the data. So this first list is to store the data which is of the images, and the next one is for the labels. So for the labels we will only have two classes. One is the positive class is the pothole class, which is one, which we'll annotate as 1, and the negative class is with the roads without potholes, and we'll annotate it as 0. So then we'll see this ROI extractor class or function. You have seen this earlier in the previous post. So if you have any doubt, please refer to the previous post 3. So, but still, let's run through it. So all what it does is it just looks at the images, extract the ROIs from the classes using the bounding boxes, and then convert them into an NP array, into an array, and then stores it. That's all what we are doing here. So the first line is where we read the file, which is using OpenCV, and then we get the bounding boxes from the CSV file. So here the input is a row, which is one of the rows of the CSV file. So like this is one of the rows. This is one of the rows. So we that's the input, and the path. The path is the path to the image. So we'll so in the image, when reading the image, we'll give the path and the row and the file name. So the row and the file name will give you the image. So this is the file name, and along with the path, we are just reading the image, getting the bounding boxes from the row. So x min, y min. So those are the bounding boxes. And then once you get the bounding boxes, you crop the image using those bounding boxes, and then you reshape the whole image using a standard size of 224 into 224. Why 224 into 224? Because this was the size where the base network, which is your mobile net, was trained on. So that's why we are kind of using the same kind of the dimensions. And then we are converting this cropped image, which we have resized, into an array, into an NP array. So this is image underscore this specific function is, we have imported it from a NumPy. So to convert into a NumPy array, and then we are pre-processing the input. What do you mean by pre-processing is, as you remember, when we read the images, their pixel values are between 0 and 255. This pre-processing function, what it does is, which is a standard function, which is part of NP array, is it converts these pixel values between 0 and 1. So that's all what pre-processing does. So that's all what this this specific function does, and then returns the ROI, or the region of interest, which is an array. So let's run this. So first we are defining the path here, which is the path to where your images are, and then we run these run a loop wherein we are running through each of those rows of the CSV file. So each of the rows of the CSV file, we are running it through, and we are taking only the pothole class, where the class is potholes we are taking, and then we are using this function to extract the ROIs, which after this function, it's just an array data. Okay, and then we are appending that array into the list which we created. So the first so the data list will append all those arrays, and then labels will append the positive class, which is 1. So that's what we'll append. So let's look at the shape of the data. So here we have only 31 examples of potholes, and so that's why it's 31. So we have 31 arrays, and then let's look at the shape of one of these arrays. So it's 224 into 24 into 3. So the length, width, and number of and the RGB dimensions. So that's how we've got the shape. Now we'll do the same thing for the negative examples also.